we're going to be hearing from Puneet Singh. Am I getting your name, pronouncing it correctly,
Yep.
Puneet?
Yeah.
From Puneet Singh of Encryption Consulting. Puneet has a background in so many areas coming out of the enterprise, his consulting with Deloitte, and his past background as a developer. Tonight, he's going to be talking to us specifically about code signing. So I'm very much looking forward to that. And take it away, Puneet.
Thank you. Just give me a second. I'll just turn off my camera so that I can have more bandwidth. Okay. Thank you. So before I get started, guys, let me get you guys a little bit background about myself. So my name is Puneet Singh, and I'm based out of Dallas, Texas. And I have worked in the space of the encryption for last 16 plus years. And in the last 16 plus years, I have worked some of the major encryption companies, such as RSA. Then I worked for Thales Security. Then I moved to consulting world, and I worked for EY and as well as for Deloitte. And after working for Deloitte, I started my own company, which, as the name says, Encryption Consulting LLC. We focus in the space of the encryption. And when I say the encryption, what we do is that we help Fortune 500 or Fortune 1000 company in rolling out the encryption, data masking, tokenization, PKI HSMs or PKI HSMs within their enterprises. We also help them with developing the strategy or the rolling out roadmap as well. And we also have an expertise in doing the assessment in those particular areas. That being said, what we are going to talk today is that we will be talking about the code signing. Then I will be exploring that what are the business threats or the risks which are associated with the code signing. We'll be also be looking at the what are the some of the best practices which needs to be followed for the code signing. I want it to be an interactive session, guys, so feel free to stop me at any slide where you want to focus a little bit more or you want me to go a little bit much more deeper. Now, first thing, what exactly is code signing? If we talk about in a layman terms, as human have got the birth certificate, which acts as an identity for them. Similarly, the EXCs or the DLLs or for the code, if you need to attach an identity to that or you want to ensure that the integrity of the code is being maintained, then you need to perform the code signing for that code, and that will attach an identity to that code. Now, how does this process exactly works? Now, if I'm a developer and if I'm doing a coding in a C, C++, or if I'm doing anything on Windows, my output would be an EXE, DLL, something like that. So what I would do as a developer is that I will generate a CSR. When I generate a CSR, I'll be generating a public-private key pair, and I submit that CSR, which contains the public portion of the key, to the certificate authority, and that certificate authority can be my in-house organization, internal certificate authority, or can be a publicly trusted certificate authority, such as Intrust, Thote, or Sectigo. And I submit my CSR, the certificate authority will sign that CSR using the private key and will return back to me a code signing certificate, and I will use that code signing certificate for signing my EXE or DLL, and that's how I'll be attaching the identity to my code, and it's kind of add the legitimacy to the authorship and everything. Now, why do I need exactly the code signing? Can I not survive with that? Yes, I can survive with that without that. But if you see that whenever you are deploying a package or anything like that on a Windows platform, you'll get a pop-up something like this. Like if you see on the right-hand side, there's a blue pop-up is there on which it clearly shows that who is the author or who's the publisher of that particular package. Now, if you don't do the code signing, you'll get a pop-up like yellow one, which gives you a warning kind of thing that, okay, I don't know who's the author of this particular EXE, or I don't know who is the publisher for this thing. So in that scenario, it's kind of, if I'm the end user, should I trust this package or should I not trust this package? Those kind of questions come to my mind. And if I go ahead with a yellow pop-up, it might add the malware to my box or something like that. And that can lead to much more bigger problems. And this is not just applicable to the Windows. This code signing is applicable to Macintosh, Linux, and everything, whatever we can think of. Now, what are the challenges people are facing with respect to the code signing, or what are the real-time scenarios or the risks? First thing is that, as I started the conversation, that developers generate the CSR and then they sign the package and everything. Now, if you think of that in an organization, there are hundreds or thousands of developers out there. So they can generate thousands of CSR. So if you see that, there are hundreds of private keys which are floating within the environment, and that can lead to the decentralization of the keys, and there will be multiple copies of the keys present floating within an organization. So key management becomes one of the biggest challenge. Now, with this second thing, which is kind of this whole process, which is ad hoc based, where developers just do the signing because I need to publish an app on the Apple Store, and Apple Store is enforcing me to have my package signed. So I have to sign it. So I will just generate using a self-signed certificate and I will sign it. And there's no like a process being followed here. It's kind of a ad hoc based process, which is normally followed within the enterprises. And there's no auditability or the accountability for that, that what time that package was signed, who signed it, whether that package was scanned with the malware scanner or not. Those are the different risks what we kind of introduced within the code signing, and these are the challenges what organizations are facing with respect to the code signing. Now, again, going back to the same thing, that people use the software based key, in the sense, in the first example, when I was a developer and I didn't know about code signing or the security that much, I will just generate using the OpenSSL. There are OpenSSL commands. I can generate a certificate. I can sign it. Or in the Windows, basically, if I don't know much, I will just set up a 1-tier or 2-tier PKI, and I will generate a certificate and I will sign it. So what's happening in this case is that the keys are getting generated within the operating system. Now, in the case of the Windows, normally Windows uses the DAPI APIs, and if a person is smart enough, and if he's a hacker and he wants to know that private key using which the signing is happening, he can easily take the memory dump at the time where the code signing is happening. Or if it's a Windows system, the key is normally stored into the registries, and if person knows it, there are different utilities like jailbreak and other things using which he can take a dump of the key and then can start signing the code or anything on the behalf of that particular organization. Second is, again, I would say that if you're using an internal certificate authority within your organization for issuing the code signing certificate or any high value certificates, and those keys are not being protected by the FIPS 140/2 level 3 compliant HSMs and everything, then the job of the hackers is very easy to take the dump of the key. Again, the last point was the ad hoc processes. We need to develop an automated process which keeps the track that who signed it. If I want to find out what were the 20 binaries which were signed in the last 10 days or something like that, with ad hoc process, I cannot find out. So we need to automate that whole particular process. Now, being a cybersecurity guy, I always tell it to my customers that you need to develop code signing as part of the software development lifecycle. If we make this whole code signing as part of the software development lifecycle, it's going to enforce the security by default in the design of the software development lifecycle. Now, if we talk about technically that how exactly the code signing works, if you see that, what happens is that whenever we write a code, that code is passed through a hash function, and that hash function produces a hash value, and that hash value is signed by the private key of the code signing certificate. And the hash value, the hash value, the certificate, and the signed hash kind of forms a bundle, and that acts as a code signing package. Now, if we think of the processes or the tools which are out there or available for the code signing, if we talk about Windows environment, in the case of the Windows, Windows provides with the Windows 2012, Windows 2016, and Windows 2019 servers are the SDKs or the signing tool using which you can sign the EXEs and the DLL. Similarly, there are open source tools available from the for Linux and the Macintosh signing as well. But I normally recommend if you're thinking from the enterprise perspective, then they need to acquire a particular tool which has all the capabilities with respect to the auditability, accountability, and following the least privilege, suppression of duties, and other things of the security. Now, once the code has been signed and it has come to the users like you and me who has to install that package on their machine, then how does that verification process work? That verification process is kind of a two-step process. First process is the hash is being verified, and the second process is that the code signing certificate gets verified. For the hash verification, the code is again passed through the hash function. Once the code has been passed through the hash function, we get a hash value, and with the bundle of the code signing using the public key of the certificate, we will get the original hash value which was attached. So now the new hash value which is computed will be compared with the old hash value, and if they both match, that means the code was not tampered or the integrity of the code has been maintained. And similarly, second step would be that certificate using which the code signing happened, that needs to be validated. For that, basically the chain building and the certificate validation takes place, that whether certificate is valid, the dates are valid, and whether the certificate has not been revoked. All those happens at the background, and this is what happens when we talk about code authenticity being verified. Now, that being said, now if we think from the normal people who don't work in the software area or who don't understand the code signing that well, normally, for example, my parents, they don't know anything like about code signing, what is code signing, and for them, basically, if a pop-up comes, I have to install it. They don't know basically whether it's a malware or whether it's a proper package or not. So normally there are three things. What I normally tell it to my family members is that, okay, whenever you get a pop-up, something like that, that you need to install or update a package, first thing you need to verify is that the publisher which is there should not be an unknown one. It should be a proper publisher. For example, if you're installing an Outlook package, or if you're installing on the Windows Microsoft update and everything, normally Microsoft will always sign their package. If it's coming as unpublisher, that means it's not coming from Microsoft. Second thing is that always verify the chain of the certificate, that whether that certificate using which the code has been signed or the package has been signed, is that whole chain valid or not. That also needs to be verified. And the last thing is that most of the times when publishers like Google, Microsoft, Apple, or anybody else who publishes the code, they normally use the public CAs, public certificate authorities. So you would easily be able to verify that it's coming either from the Interest or DigiCert or somebody like that. So that whole chain should be verified well. Now, another thing would be that, okay, for example, Puneet told that, okay, the code signing is there. We need to verify the pop-up and everything. Now, if my parents goes to Walmart and they bought a package of installing a Microsoft Office on their laptop, and that DVD which they bought, or the package which is there inside the DVD, would have been signed somewhere like if they bought in 2018, will they be able to install that software package in 2021? Yes, but the certificate which was put it on that code signing would be just valid for 1 year. Now, that's where the time stamping certificates comes into picture. Even if the package was signed with a certificate which has expired, but if the time stamping certificate is attached to that, the time stamping certificate acts as a notary, and it will tell the machine that at the time when this package was signed, the certificate which was attached to that was still valid. And normally, how does that time stamping works? This portion I will just read through the slide, because it's kind of a step-by-step process. The signature is sent to the time stamping authority, and the time stamping authority adds a timestamp to the bundled information and computes the new hash. And then the TSA signs the new hash with its private key, creating a new bundle of information. And the time stamped bundle and the original bundle that was sent to the TSA, and the timestamp is rebundled along with the original code. So if you guys are developers, and if you're writing the code, and if you're signing it, ensure that you are using the proper time stamping authorities as well. DigiCert is one of the time stamping authority which is most commonly used. There are others as well available there. I believe Interest also provides that. And always use the time stamping along with your code signing. It's not necessary, but it would be good to use it, especially if you're making the softwares which you're making are going to be publicly available, then you need to do that. Now, another challenge what I have seen in the organizations with the different developers is that sometimes the developers use the self-signed certificate for signing the code, and the reason for that is that most of the people by default doesn't want to follow the process, or they don't want to buy a public CA certificate, because there's always a cost associated with the public CA certificate. So that leads to a much more bigger problems, because if something goes wrong, there's no way to revoke the self-signed certificates. So if you're doing the code signing and if you're dealing with it, always get a certificate from the public trusted certificate authorities, or if that code is going to be deployed internally within your organization, then get a certificate from your central PKI, so that if something goes wrong, there is a way to revoke it and to control or do the damage control. Now, there has not been much work done in the code signing areas, and there is not a minimum requirements defined either by the NIST or the CA CAP forum. I know on this slide, the maximum validity period is written as 39 months, but as per the CA CAP forum and the Apple recently launched the guidelines that the certificate validity should be of the 398 days, which roughly equates to 1 year. So if you're using the code signing certificate, or if you're doing code signing within your organization, try to get a certificate of 6 months, because it's a high value certificate and it's better to rotate those keys as soon as possible. Second thing what I would recommend is that NIST recommends that to use minimum of RSA 2048 or the elliptic curve cryptography. I would say there is a site called keylength.com. Look at that, and I would always go a little bit higher than what NIST recommends. So if NIST is recommending me RSA 2048, I will go with the RSA 4096-bit key, and even on the elliptic curve cryptography, getting a much more better algorithm. Then other thing to keep in mind from the requirement perspective would be that if your organization have gone through the different attacks or had any attack recently on the private keys or try to use the FIPS 140/2 level 3 HSMs to protect the private keys for the root CA, for your root CA, issuing CA, and the code signing certificate keys as well.
Oh, did we lose you, Puneet?
The last thing I would do. Okay, hello.
Sorry, we lost you for 1 second. Can you just back up just a tiny bit?
Sure. So where did you lost me? Was it the minimum key size, or where did you lost me?
Just right there at minimum key size, yeah.
Okay. So if your organization has a history of takeover attacks, it's better to use the private key protection using the hardware security modules, which are FIPS 140/2 level 3 compliant. And also, if you're using the code signing, have to inbuild the process for using the time stamping servers. Now, let's talk about some of the best practices which are out there with respect to the code signing. The first thing is that try to have the permissions on your private key. From the permissions perspective on your private keys, try to follow the principle of the least privilege, so that all the high value keys, whether it's a root CA, issuing CA, code signing certificate, not each and every employee should have an access to that. Secondly, in spite of having a decentralized approach that all the developers signing the packages have a kind of a centralized kind of a platform, which would basically help like centralizing the keys and decreasing the possibilities of the compromises. Third, try to have a separate certificates for both development, QA, as well as for the production environment. And the last, try to have the time stamping done for the code. Now let's talk about a case study. I'm pointing here to the case study of the Duqu 2.0, but this was a similar case what happened to the Ashes a few years back, where they had a malware in their motherboards or the firmware. So in the Duqu 2.0 attack case, what happened is that somebody kind of stole the private keys, and using those private keys, they signed the malware and inserted that malware into the different firmwares of the hardware, and that led to a much more bigger problems. And if people were careful and they would have followed the proper audit controls and kind of a centralized process, that would help them a lot. And I would recommend that every one of you, that if you're doing the code signing, have a centralized process or use a particular tool for that. That being said, I would still like to add that my company, Encryption Consulting, has a tool called My Code Signer, and using that, we support Windows, Linux, Macintosh as of right now for signing, and it is integrated with all the major HSM providers such as AWS Cloud HSM, and Cypher, SafeNet, and FutureX. Thank you, everyone. And guys, here are my contact details. And if you guys have down the line also any questions, feel free to reach out to me, and I will take the questions here on. And as everybody puts the question on chat, or how does that work?
Yeah, thank you so much, Puneet. We're a small group tonight, so if you feel comfortable, go ahead and unmute yourself if you have a question. I'm also happy to read your question if you want to put it into chat for us. Maybe I'll kick us off and just kind of wait for just a second here. That circular slide that you had back there 4 or 5 ago, I wanted to ask you about, kind of each of those elements and, how often all of them are required. Is it possible for you to go back to that? Oh, it might be losing your audio, Puneet. Just give him a second to come back here. Harsh, you're with me, right? It's not my connection.
Yeah, no, I'm with you.
Okay.
You too, Bradley.
Great. Let's just stand by here and see if Puneet comes back for us.
You can just blame it on Texas.
This is where I start telling dad jokes, when the connection fails. Yeah,
I'm all ears. I want to hear them.
Well, the question, and maybe you can speak to this a little bit, Aaron, and Puneet can take over, but the question was around all of these elements. I very much appreciate the visuals in his slideshow kind of laying out how these pieces fit together. And, I was just wondering if, each
Can
of
you
those
hear me, guys?
Yes, perfect. That's exactly
Awesome.
exactly the slide I was talking about.
Okay.
And I was just about to ask my question, Puneet. So are all of these elements, required for every compatible code signing for each organization? Or, do some of these, essentially not apply? Like, would you always want certificate revocation, or would you always want a validity period?
So these are like a good practices to follow a minimum requirement. As I said, there is not a mandate or there is no regulatory requirement basically for the code signing, but these are the kind of what I have seen in the industry or what I feel are the good thing. There's nothing like a NIST or the FIPS or anybody is dictating any requirement with respect to the code signing.
So if, for example, as an independent developer, I wanted to publish something on the Windows App Store, the Microsoft App Store, would all of these apply, or would just some of them?
I'm losing him again as well.
Yeah. Well, when he comes back, we'll see if maybe he can move a little closer to his Wi-Fi. I've never had to go through code signing stuff for universal Windows applications, but I have navigated Apple's draconian structure around it before, and it's interesting.
Draconian is putting it quite nicely, yes.
I think Jason might have even more experience with that.
Oh man, talking about some battle scars.
What? If you read their documentation, you just pay them $100 and then it magically shows up on the App Store. Is that not right, Jason?
If you were the right person.
They've gotten better since they've automated some of it through Xcode, but it's still not perfect. But God, when the App Store first came out, it was a true nightmare.
I mean, it's telling that if you want to write an app in Xamarin, you still need Xcode for all the code signing. So you need an entire IDE to follow Apple's best
guys, I'm back
practices.
again. I don't know what's happening to my internet today.
That's all right, Puneet. Is it maybe a range issue? Any chance you could move closer to Wi-Fi, or is it?
Yeah, I am sitting next to my router and I have a static IP address and I never had a problem. This is the first time I'm having a problem. Okay, so I was answering your question. If you want to publish an app, if there are two, let's take about 2 examples. One is that you are an individual user and you want to publish your app on the App Store. for you, basically, it would be better if you get a public CA certificate. It won't be expensive. It would be roughly $75 to get a certificate from either from the DigiCert or Sectico or Thote, and then do the signing, so that everybody can trust that package, because that's coming from a public CA. If you're working like an internal scenario, like testing something, then you can use the self-signed certificate. So all these requirements are not applicable. But if you're working at the enterprise level, like a maybe big company, basically with 100 plus, or you're publishing something on behalf of your company, then I would say you should follow everything which is there. It depends on use case, but again, I would repeat it here that there's not a regulatory or there's no standard defined by NIST or FIPS for the code signing that you have to do this or that kind of thing.
Right. Yeah, that makes sense. Any other questions out there?
Yeah. So hold on one sec. My dog just decided to start speaking. All right. Hey, so I got a question for you about Android application signing. Mm-hmm. So at a previous employer, we had a app that was signed by a private key that was only stored on one developer's laptop. In India, the laptop got stolen. We lost the private key. We had to basically start from the beginning. When you think about the private key that signs application code on app stores for iOS or Android, as it pertains to a CI/CD pipeline, what are your thoughts around how do you protect that key? How do you back up that key? And how do you ensure that only authorized users have the ability to publish code through your CI/CD pipeline that is actually authorized and signed by the company, even though an automated system is signing?
So I would put that key, that was one of the problems that I mentioned, that developers keep those keys on their laptop and then they lose it. So put those keys into the HSM, hardware security module. You don't have to buy the most expensive hardware there, but if you can buy a cheapest one as well out there and have a kind of a centralized platform for the code signing, using that, you should do it. And when you're backing up that key on the HSM, even if you lose a laptop, it doesn't matter. You have the HSM in the office, and that contains the that contains the key, and it's kind of you're centralizing the keys and everything. Does that answer your question? So you don't have to back up because it's on the HSM. Secondly, it's not a developer responsibility anymore. He has to go to a platform basically to do this, like a signing and everything. And that's where means I'm not publicizing my platform. You can use anybody else's platform, but that's the reason we built this platform, because people have this problem or the gap.
Yeah, so it totally makes sense. When you think about like the PKI signing though, does it make sense to build any sort of internal PKI system where you use like a trusted root certificate trusted by a third party to generate your own signing keys?
So here's the thing. Are you going to use this software within your enterprise, or are you going to use this software outside your enterprise? Can you answer that for me?
Yeah, in this particular case, this would be a third-party distributed application, so outside the enterprise. So
if you're using for testing, till the time it's happening within your enterprise, use the internal CA. But if it's going to be distributed to the third parties are not going to trust your root CA or the issuing CA. They are going to trust the certificate authority like Intrust or the Thote. So you need to get an external code signing certificate from there. Otherwise, you will be distributing your internal root CA and issuing CA certificate to everybody, so that they have to install your root CA and issuing CA to trust that code signing certificate. And you don't want to be in the business of distributing the certificates. Am I making sense, Adam?
Yeah, it certainly makes sense.
So Adam, you're seeing my screen, right?
Yes. Yeah. Couldn't find the unmute button, but yes, I am.
So if you built the software and you signed it using the like a third-party certificate, and like these certificate authority like Thote and everything by default like would be there on the machine of the everybody else. So you don't have to do any kind of a thing. You sign it using the public CA, and all those certificates will be by default built in everybody's boxes. So your your life will become much more easy if you use the public CA certificate if you're distributing outside. But for testing purpose, to keep the cost low, you can use your internal PKI. Now, should I go a little bit more deep on that, Adam?
You might hold off on that. Let's just make sure if there's other questions, I want to make sure that we get to everybody here. Anybody else out there with a question? Otherwise, feel free to expand on that.
This is Aaron. Yeah, I gotta ask. Hey, Puneet, that was awesome. Thank you so much. I'm gonna have the camera off because I'm in the middle of dinner here. But can you talk about the role of PKCS 11 with storing keys on that HSM so that folks could sort of paint a picture of how they could set something like this up themselves?
Sure. Okay, guys. So the thing is that, Alan, I will go a little bit much more deeper on this. So normally when we talk about HSMs, the HSMs, what I was talking about are the general purpose HSM. Okay, when I started this conversation with the Bradley, in the starting of discussion, I talked about payment HSMs, but we are not talking here about payment HSM. We are talking about general purpose HSMs. Now, the general purpose HSM and the payment HSM have a difference. The payment HSM don't expose any APIs, whereas the general purpose HSMs exposes 5 APIs. The 5 APIs which general purpose HSMs exposes are PKCS 11, CAPI, CNG, CHIL, JCE/JCA. Now, PKCS 11 is kind of a protocol or kind of a protocol which is being followed by the most of the general purpose HSMs for storing the keys. But as I said, it's not only the interface using which you can store the keys into the HSM. Normally, if you're dealing with the PKI, in the case of the PKI, they normally use the CAPI and the CNG mainly in the Microsoft case. But if you're talking about the DigiCert PKI, or if you're talking about the Interest PKI, they use the PKCS 11 interface for generating the keys. Now, Adam and Aaron, your question are kind of little bit interlinked. So when you will generate a CSR, and if you want to store the key basically for the DigiCert, you can use the PKCS 11 interface for the DigiCert. But if you're using the Microsoft PKI, then you will be using the CAPI or the CNG interface for storing the key inside the HSM. Guys, did I went through too much? Or was it?
That was perfect. But yeah, PKCS 11 works across a lot more platforms, and as you pointed out, CNG and the CAPI are at Microsoft. But I was just trying to get an idea how, when you generate that CSR, how you can actually get that private key to be created in that secure enclave. And I think you just nailed it. So thank you.
I just want to add in a little bit here that the 5 interfaces which I talked about, general purpose HSM, it's not vendor specific. It's each vendor, whether it's Encipher, SafeNet, or FutureX, they all support all these 5 interfaces. Or the AWS Cloud HSM as well.
Thank you. I use PKCS 11 with Nitro keys. To do exactly.
Yeah.
But I mean, that's a $70. But it'd be a great option, if somebody wanted to do private key storage.
Mm-hmm.
It's not centralized usually. They're small little devices. But
you can buy the YubiKey as well. I don't know how much is YubiKey, but YubiKeys are also pretty cheap.
Aaron was talking a little bit about those last time. One service that has become more and more utilized, at least for web stuff, but increasingly like NAS and data storage is Let's Encrypt. Do you have any knowledge in terms of how? Obviously, those are much shorter certificates. I believe they're all 3 to 6 months in duration. As far as are best practices being followed there?
For the NAS encryption?
Well,
Oh,
I use Let's Encrypt for my NAS so that I can get to it, from the public internet. But I think, Let's Encrypt has kind of been an out of the box solution to have, free, typically browser based security for consumer products, for individuals rather than businesses to, deploy a NAS that they can get to from grandma's house. And I think I'd be curious to know if organizations like Let's Encrypt, which I think are nonprofit, are making that work.
I have not used, to be very frank, Let's Encrypt because even for the NAS and everything, when I deal with my customers, they are more bothered about file and folder and the element level kind of encryption, and I normally go with a transparent data encryption, TDE, and there are different options which are available there. So I normally go with that. So I've not, as I said, I haven't used the Let's Encrypt yet.
Any other questions?
Come on, guys, it was not that boring topic.
I'll throw another one out there then. I'm curious, do layers keep getting added onto this? We're still looking at your chart here, and you have kind of 8 distinctions. But, it seems like these are all to cover specific attack vectors. Is that presumably there's going to be additional requirements for code signing in 2025, 2026 and onward?
I think so, but as I said, maybe down the line, maybe PCI or any other regulations will start focusing on it, and they can add more requirements to that. But as of right now, as I said, nobody's it's good to have, but it's not must to have kind of thing. So until unless somebody get breached, basically like issues or somebody like that, something happens, then only they go and do the things right. Otherwise, it's not a must to have. So let's keep on running the way it's running.
Right. Well, and you mentioned you're consulting with Deloitte before, and you obviously have some understanding of European regulation. Are any of these best practices required in Europe?
If we talk about GDPR, which is the most prevalent law in Europe, the GDPR has article number 72, which talks about encryption. They also talk about pseudonymization, which I call tokenization, and anonymization, which is data masking. But they have not exactly called about the code signing. They talk about when they use the terminology articles number 72 for the encryption. It's a little bit loose terminology that you need to use the proper algorithms. Now, if you say that here for the code signing, I am telling that you use 2048-bit RSA. So it's a proper algorithm. So they are not calling out code signing, but they are talking about use the proper cryptography in the GDPR.
Yeah, that's very interesting to know that's kind of the best law of the land, and that's as far as we go so far.
Yeah. But I think things are getting improved. If you look at the CCPA, California Consumer Privacy Act, New York NYDFS, if we look on the healthcare industry, HIPAA, high-tech, and then we look at the financial industry, PCI and others, they have written about encryption. They are talking about tokenization and masking, but not going to the like a nitty-gritty that you need to do this or that kind of thing.
All right. Any other, I would say, prompt for the last question of the evening, if anyone's got one.
Well, hopefully this is good enough for the last question of the evening. So when it comes to the nitty gritty, right, I get that no governing body has necessarily talked about exactly what needs to happen prior to code signing. But can you talk a little bit about how do you verify authenticity of code leading up to the final product being signed? in particular with respect to automated systems on like GitHub that do CI/CD for the intermediary commit level signing.
Mm-hmm.
How do you think about protecting and using those keys in automated systems?
So that's where my tool, which is there, my code signer, which is there. It's kind of as soon as you do the build with the GitHub and everything, we have an integration of the tool. And as soon as you commit the code, basically, it gets signed immediately. And authenticity is again, basically, I will go back like before I go back, just a second to answer your question. You can still see my screen, right?
We can.
Oh, come on. Where's my, I put it a file. Oh, here we go. So it was Adam who asked the question, right?
It was, and we are just looking at your slide deck still,
Oh.
not anything else. So just so you're aware.
Stop share, and screen share. Can you see that? My file with the 2 signed and unsigned?
Yes.
Okay, so for verifying the authenticity, if you see here, if I go here, properties, I don't have a digital signature on the unsigned file. If I go here, properties, if you see, I have a digital signature. Let's compare these two here. Do you see the 2 MSI packages? One MSI package has a extra box, which is a digital signature. It tells me, whereas this one, it doesn't have a digital signature. And if I go here, if I look here, details, this is self-signed certificate, so it's showing like that. But if I want to verify, I can verify that this package was signed by the Encryption Consulting, and I use the common name Puneet this thing. But here, using this whole chain basically of the digital signature, I will verify the authenticity. And whereas as a package which is not being signed, I can easily, not through the eyes as well as through the process, I can make it out. And this thing can be like in line with the CI/CD process, where if you are checking in anything on the Jenkins or anything like that, it will trigger the signing process and everything. And when the signing is happening, it's going to validate that the digital signature, whether that digital signature is valid or not. And in that validation process is going to check that it came from the proper certificate authorities and authority. Adam, does that answer your question?
Yeah, that's great.
All right. Well, with that, we are at 8 o'clock here in Alaska. So I want to thank you again, Puneet, for a very interesting discussion on code signing and introducing a lot of those concepts to me. I appreciate it. And we will be back next month with another speaker. So I hope you all have a very good evening, and we will see you next month.
Thank you, guys.
Yeah, thank you.
Thank you.